Okay, students, so just now we discussed theory of flywheel and we derived the mass moment of inertia of flywheel expression. So now I am going to explain the flywheel apparatus setup. This is the flywheel apparatus setup. So see this one, this is the flywheel of mass 7.5 kgs denoted by capital M, which is mounted on a axle. So here one thing, that is radius of the flywheel is 125 mm. So it is mounted on an axle of radius smaller, that is 19 mm, which is mounted on a, keep it on a supports here on bearings to reduce the friction. And here we can see a cord is attached to the axle, one end, and other end a weight hanger is attached to the cord. Okay, here we see, so some provision is there. So to keep the slotted weights, these weights are called as a slotted weights because it has a slot to insert into the weight hanger. Okay, so this is about apparatus. Okay, now I am going to explain the tabular form. So this is the tabular form. Here we can see here mass, so denoted by small m, so units are kg. So we attach these slotted weights to the hanger. Already I showed to you earlier. So we note down the mass of the slotted weight here. Here we see the mass of the slotted weight is I think 230 grams. Here the mass of this slotted weight is 100 grams. Here in this experiment we are using these two slotted weights. Okay, so now actually these are in grams. We need to convert into kilograms and add the hanger weight also. So the hanger weight is 108 grams. Okay, you add the hanger weight 108 grams to the weight which is attached to the hanger. Okay, suppose this is 230, then the weight is 230 plus 108. That's simple. Okay, so now, so coming to the second one, that is average time, T. Okay, here we are measuring the time, how much time it takes to fall the load hanger from this plate to the floor. Here the distance from reference this plate to the floor is 1 meter, that is denoted by small d. By using a stopwatch, we measure how much time it takes from here to travel from here to floor. So that is T. Note down the T value here. So we do this experiment 2 times by using 2 different weights. So here first weight we note down here, and the time, how much time it takes to fall to here, you note down here, and take another mass and note down the time how much it takes. Okay, so after getting these values, okay, here we see in the third column acceleration. This is linear acceleration. Anyway, we know we have 2 types of accelerations. One is linear acceleration, the second one is the angular acceleration. Here this is the linear acceleration. The formula is A equal to 2d by t square. So this is we're getting from equations of motion. Here d is distance. Already just now we explained. So that is 1 meter. Then coming to t value, already it is there here. So substitute there, we get the linear acceleration. So units are meter per second square. Now in the next column we see that angular acceleration. We find the angular acceleration. So anyway, we know the relation between linear acceleration and angular acceleration, that is Suppose coming to velocity v equal to r omega. So coming to acceleration, all right. So a equal to r alpha. From that angular acceleration alpha equal to a by r. Here a is linear acceleration. Okay, then coming to small r. So this is radius of the axial, that is 19 mm. Convert into meters. So that is 0.019 meters. Now the next column, next value, that is the tension in string. So denoted by T. The formula to calculate the tension in the string, T equal to m of g minus a, units are newtons. So here small m, we take this value from here, and g, that is we know very well, that is acceleration due to gravity, that is 9.81 meter per second square. A, take this value from here, and now coming to the torque, the next one is torque. So tau equal to tension T into small r, that is axial radius. Units are Newton meter. Now finally, that is we are going to calculate the mass moment of inertia, that is from practically, that is from experiment. The formula, that is IP equal to tau 2 minus tau 1 by alpha 2 minus alpha 1. Units are kg meter square. So anyway, we get the alpha tau 1 value here from first readings, tau 2 value from second readings. So then alpha 1 from first readings and alpha 2 from second readings. Substitute it here in this formula, that is IP equal to tau 2 minus tau 1 by alpha 2 minus alpha 1. So calculate and solve it, we get the mass moment of inertia, that is practical value. So the final value, that is theoretical mass moment of inertia. The formula, that is half mr square. Here m is capital M. So already we know that is capital M equal to mass of the flywheel, that is 1.5 kgs. So capital R, so that is radius of the flywheel, that is 125 mm. Convert into meters, that is 0.125 meters. Substitute there, we get the theoretical mass moment of inertia. Okay, so now I am going to run the experiment. Okay, now I am doing the experiment to calculate the mass moment of inertia, that is practically. Okay, anyway, we know this is the weight hanger. So now I am taking two slotted weights of each of 230 grams for first reading. Okay, so now I am inserting the slotted weights to the weight hanger. You can see here. Okay, so this is the first slotted weight of 230 grams. Anyway, you should add hanger weight also, that is already known, that is 108 grams. The second slotted weight I am inserting. Okay, right. So now the mass, that is 230 plus 230 plus okay, anyway, hanger weight, that is 108. The total is how much? That is 568 grams. In kgs, that is 0.568 kgs. Yeah. So this is the mass, first mass. Now I am measuring the time, how much time it takes to fall from this reference plate to the floor. So with the help of stopwatch. Okay, release that. Okay, now it reaches the floor. So, how much time is taken? Okay,
it is 7.66.
Okay, so 7.66 seconds. So now I am doing the experiment second again for another.
It is 7.66.
Yes, 7.66. Okay, so by adding two more slotted weights of each of 100 grams. Okay. Now the mass is, so that is 108 plus 230 plus 230 plus 100 plus 100. Okay, then so 108 plus 230 plus 230 plus 100 plus 100. Okay, 460, 568, 768 grams. In kgs, that is 0.768 kgs. Now I am measuring the time, how much it takes to reach to the floor from this plate. So with the help of stoppers. Okay. How much time?
It is 6.70 seconds.
Okay, 6.70 seconds. Okay. So the time is 6.70 seconds.